Algebra.
When you have two xy points, you know that you can always draw a straight line through those 2 points. You can also figure out how that line is sloping or pointing by plugging those points into this formula and then doing the arithmetic on the top and the bottom. This formula can be a challenge for some people to use, so I'm going to show you a very easy way to use this, but first I'll briefly describe the standard way it's used. Because of the way the numbers are arranged in this formula, you have to carefully label each point, then place each number into the proper slot in the formula. Next, you do the arithmetic on the top and the bottom to come up with the specific numbers that describe the direction the line is pointing and how steep it is, or what's commonly called the slope. For example, if you have these 2 points, the standard way you find the slope is to first label them point 1 and point 2, then label the x and y numbers accordingly so that you know where to put them in the slots in the formula. Then you perform the arithmetic on the top and the bottom to find the slope. Well, that's a pain in the butt to try and keep everything straight by doing it that way. So we're going to forget about that and do it another way. So let me do this problem with a different, much easier method. First of all, with this method, you never have to label the points or the individual x and y numbers. You do need to remember that the y numbers always go on top and the x numbers always go on the bottom. Well, you don't even have to remember that, but it's a good idea if you do. Let's take these points again, 4, 7, and 3, 2. You know that in ordered pairs, the ordered means that they are always in a certain order, meaning that the x value is always the first number and the y value is always the second number. Now I'm going to write 2 sets of parentheses with a minus sign between them so I can place the numbers in them. Now here's the easy part. You just place one point in front of the formula and the other point in back like this. It doesn't matter which one goes first or second, and I'll do these both ways to show that it doesn't matter. Now remember 2 things here. In the points, the x number is always first and the y number is always second. And in the formula, the y numbers are always on the top and the x numbers are always on the bottom. From the points, take the y numbers and stand them on top of the x numbers on both of them like this. The rest is easy. Next, you just slide the numbers into the parentheses like this. So as you can see, we didn't have to use any fancy labeling to get the numbers from the points into the formula. The next step is to do the arithmetic across the top to get a number on the top, and the arithmetic across the bottom to get the bottom number. 7 minus 2 is 5, and 4 minus 3 is 1. This says that the slope, or the way the line is pointing that goes through the points 4, 7, and 3, 2, is 5 over 1. It says 2 things, and I'll go more into detail on these in a minute. It says that the line is pointing in a positive direction because the number plus 5 over plus 1 is positive, and that it's much steeper in the y direction than in the x direction because it travels 5 units up in the y direction for every 1 unit over in the x direction. Remember, the y values are always on top and the x values are always on the bottom. I did this problem with the point 4, 7 first and the point 3, 2 second. Let me switch the points around and show you that it comes up with the same slope. Just like the first problem, I stand the y numbers on top of the x numbers like this. Next, I slide the numbers into the slots in the formula. Now all I have to do is the arithmetic across the top and across the bottom. 2 minus 7 is minus 5 on the top, and 3 minus 4 is minus 1 on the bottom. The 2 minuses combine to an overall plus for the fraction, so as you can see, we wound up with the same slope, positive 5 over 1. Again, this tells me that the line is pointed in the positive direction, and it rises in the y direction 5 times faster than it travels in the x direction. And that's all it tells me. It doesn't tell me exactly where it is in the graph. For that, I'd have to actually graph it. Now let me explain the idea of slope before we do more examples. A line can be pointed in 4 general directions in a plane. The first way is straight up and down or vertical. A vertical line has no slope. The second way is a line that is horizontal or flat. A line in this direction has a slope of 0. Now if you look at a computer keyboard, it has a forward slash key and a backward slash key. The backward slash key points in this general direction and the forward slash key points in this general direction. When a line points in this general direction or forward, it means it has a positive slope. When a line points in this general direction or backwards, it means it has a negative slope. Let me show you 4 examples that represent the 4 different general directions of a slope or in other words, the direction in which these 4 different lines are pointing. All 4 of these sets of points represent lines that pass through them, and those lines point in a certain direction. For the first one, I want to find out which direction the line is pointing and how steep it is from these 2 points. For the first set of points, -4, 2, and 3, -1, I first place the points on either side of the formula. Next, I move the y-coordinates above the x-coordinates. Then I move them into the adjoining slots. Next, I do the arithmetic across the top to get a 2 minus a minus 1, which is the same as 2 plus 1, because a minus in front of a minus makes an overall plus. So 2 plus 1 is 3 on the top. Next, I do the bottom numbers. -4 and -3 is -7. The plus sign on top and the minus sign on the bottom combine to give an overall minus to the fraction. So the slope of the line that goes through these 2 points is -3/7, or 3/7. And because the slope is negative, the line points in a backward slash direction. Now for the next set of points, 6, 2, and 5, -2. Again, place the points on either side of the formula. Then move the y-coordinates to the top of the x-coordinates and slide them into the slots in the formula. For the arithmetic on top, 2 minus a minus 2 is the same as 2 plus 2, because the 2 minuses combine to make a plus. On the bottom, 6 minus 5 is a 1. A plus on top combined with a plus on the bottom is an overall plus for the slope. So the slope is +4/1. You could also write the slope as just +4, but I'll keep it in a fraction form so you can see that the line rises 4 times in the y direction for every 1 time it moves over in the x direction. And since it's positive, it points in a forward slash general direction. Now for the next set of points, 3, 2, and 3, -4. Place them on either side of the formula, then place the y numbers on top of the x numbers. Slide the numbers into the formula and then do the arithmetic. On the top, 2 minus a minus 4 is the same as 2 plus 4, since a minus and a minus combine to be a plus. 2 plus 4 is 6 on the top. On the bottom, 3 minus 3 is 0. When you get 0 in the bottom of a fraction, it's a special case. It means that the line is straight up and down or vertical. So whenever you compute a slope from 2 points and you wind up with a 0 in the bottom, it means that the line goes straight up and down. Now for the last set of points, 4, 3, and 5, 3. Just like the previous problems, align the points on either side of the formula like this. Stack the y's on top of the x's, then slide them into the slots. On the top, 3 minus 3 is 0, and on the bottom, 4 minus 5 is -1. As you can see, we wound up with a 0 on the top this time, and this is another special case regarding slopes. When you solve for a slope using the slope formula and get a 0 on the top, it means that the line is flat or horizontal in direction. It's a good idea to remember these 2 special cases regarding line slopes. Let me recap on the 4 basic ways a straight line can be sloping or pointing. In the first set of points, you can see that the slope is negative, so the line is oriented or pointed in the backslash general direction. I don't know exactly where the line is located. All I know is that it's pointing in a negative direction, and it's sloping more in the x direction than in the y direction because it moves 7 in the x direction for every 3 times it moves in the y direction, which means it's more flat than it is steep. For the second set of points, I know that the slope is positive, so it's pointing in the forward slash general direction. Again, I don't know exactly where it is on a graph. I only know that it's a lot steeper in the y direction than the x direction because it moves 4 times more in the y or up direction for every 1 time it moves in the x direction. In the third one, I know that if I get a 0 in the bottom of the formula, that the line is vertical or straight up and down. In the fourth one, I know that when I get a 0 on the top of the formula, that the line is flat or horizontal. When you have 2 points, you can plot them on a graph, then draw a straight line through those points. For example, if we take our second example, the points 6, 2, and 5, -2, we can plot them, then draw a line through them. Using the slope formula, we were able to compute the slope of this line, which was 4/1, or 4 in the y direction for every 1 in the x direction. This told us that the line is steeper in the y direction than it is in the x direction, and it was also sloping in the positive direction, which can be seen in the graph of the line. This line can also be described by the equation y equals 4x minus 22. So how do we get that equation of this line? We first need the general form of the slope-intercept equation. If you look at this equation, it's already in the slope-intercept form. So, then how do we get from this general form to this specific equation? I have to first explain this equation. There are several different ways you can arrange a general linear equation, and this is just one of those ways to do it. The reason you might want this form is because it can immediately tell you several things just by looking at it. First of all, in this form you can immediately tell what the slope of the line is. It's just the number multiplying the x value. Here it's m. Another thing you can immediately tell is where this line cuts the y-axis on the graph. It's simply the b value. So just by looking at this equation, I can tell that the slope is positive 4 because that's a number multiplying the x value, and it cuts the y-axis at minus 22 because that's the b value. Now, how do we find the equation of a line if all we have are 2 points and a slope? Let's construct the equation step by step. First of all, if we know the slope of a line, we can just plug it in place of the m. Here we have the slope 4 over 1, which is just the same as 4. I can plug it in place of the m to get our first step. Next, we have to figure out what b is. We do that by using one of the points we used to find the slope and temporarily plug it into the equation. We could use either one, so let's take 6, 2. Remember, an ordered point means the x value is the first number and the y value is the second value. Plug the 6 in next to the 4 and plug the 2 in place of the y. Last, we just do the arithmetic in order to solve this equation for b. First, I multiply the 4 times 6 to get 24. Next, I move it over to the left side, and it becomes negative when I move it across the equal sign. Then I combine a minus 24 with a plus 2 to get a minus 22. Last, I just plug in the minus 22 back in place of the b, and we get our final equation of the line. There's a lot of arithmetic and a lot of steps to remember, but it can be done. So we were able to start with 2 points, then with the help of the slope formula, find the slope of the line that passes through those 2 points. Then, with that information, we were able to find the equation of that line by using the general slope-intercept form of an equation. I could have used the other point to find the value of b if I wanted to. I can use any point off the line to find the b value if I want to. If I chose to use 5 minus 2 instead, here's the arithmetic involved. I plug in 5 for the x letter and minus 2 for the y letter. I multiply 4 times 5 to get 20. Then I have to move the 20 over to get the b by itself, and it becomes minus 20 when I move it across the equal sign. Next, I combine minus 20 and minus 2 to get minus 22, which is the same value I got using the first point. Now I just plug in minus 22 in place of the b, and I have my equation of the line. Now let's look and see if we can do the first example I showed that involved fractional numbers in the slope. The points are minus 4, 2, and 3, minus 1. I can plot these 2 points, then draw a straight line through them. You can see by the slope we found that the line is supposed to point in the negative or backslash general direction, which it does by looking at the line. You can also see from the slope that it points more in the x direction than the y direction, and again, as you can see by the line, it's flatter than steeper. As before, I'm going to give you the equation that describes this line. It's y equals negative 3/7 x plus 2/7. So, using this information, how do we get from here to here? Again, we need at least one point, the slope we found, and this general form of the slope-intercept equation. The first step is to simply put the slope we found in place of the m letter. So I plug in the minus 3/7 in place of the m. Now I have to choose one of the points, so I'll pick the 3 minus 1 point and use that to find the b number. I then place the 3 from the point in place of the x in the equation, and place the minus 1 from the point in place of the y in the equation. Now I just have to do a lot of fraction arithmetic to get a number on the left side and the b by itself on the right side. First I have to multiply or simplify the minus 3/7 times 3 to get the fraction minus 9/7. Then I have to move the minus 9/7 to the other side and it becomes positive. In order to combine the fraction with the whole number 1, I have to first rewrite 1 as the fraction 7/7, so I can combine it with the fraction 9/7. 9/7 minus 7/7 is 2/7, so b is equal to the fraction 2/7. Now all I have to do is replace the b in our original equation with positive 2/7 and I'm done. Now for the one with the vertical slope, or where 0 wound up in the bottom of the fraction. This one's kind of tricky. First I plot the 2 points on the graph. Next I can draw the line passing through those 2 points. Now the problem with finding an equation for this line is that you can't use a slope-intercept here because this line has no slope and dividing by 0 is not allowed in math. So we can't use this in any kind of arithmetic. We only use it to look and see that we wound up with a 0 in the denominator, and so we know from that information that it's vertical. We're going to have to use reasoning to come up with this equation. There's two things here that can help write this equation. First is the definition that when a slope has 0 in the denominator, that the line is always vertical or straight up and down. Next is that when you know one of the slope numbers is 0, you look at the points again, and here you can see that the x values are the same. Another way to put that is that x is always 3. Now I can write an equation just the way I said that, x is always 3. When you have equations that always just involve x on an xy coordinate axis, it will always cut through the x-axis at the number given in the equation. Here the number is 3, so that means that this line will cut through the x-axis at x equals 3. What if someone gives me the equation x equals -5 and asks me to graph it on the xy plane? I know it has to cut through the x-axis at -5, and it has to go straight up and down in order to cut through the x-axis line. Where would the line x equals 0 be on the xy plane? Well, it cuts through the x-axis at x equal to 0 and goes straight up and down. So it just happens to be the y-axis line. Now what about the last one where 0 wound up in the top of the slope? With this slope, you can use the slope-intercept form to find the equation since 0 in the top of a fraction is allowed and it's just the same as 0. But let's use reason again to see if we can come up with the equation to this line. First, I plot the points, then draw a line through them. Now how do I figure out the equation? Well, when I have 0 in either the top or the bottom of the slope, I look back at the points and see which one stays the same, the x values or the y values. Here the y's are both 3, so I can write this as an equation, y is always equal to 3. Now looking at the equation, it tells me that a line always cuts through the y line at 3, and in order to cut through the y line, it has to be flat or horizontal. What if I have the equation y equals 0? Where is that located? Well, it's cutting through the y line at 0, and in order to cut through the y line, it has to be horizontal. So it's really just the x-axis line. What about y equal to -8? Where is that located? Well, it cuts through the y line where y is -8, and it has to be horizontal to cut through the y-axis. Let's take one final look at what we did in this video. We were able to start with 2 points, then using the slope formula, find the slope of the line that passes through those 2 points. Then we took that information and was able to come up with the equation of the line using another formula or template. We also learned that a line that has a positive slope points in this general direction. It could be located anywhere on the graph, but it still points in the forward// direction. And a line that has a negative slope points in the backwards general direction. And again, it doesn't matter where it's located on the graph. It still points in the / general direction. Then we had 2 special cases where the slope had a 0 in the bottom or the top of the fraction. When you compute the slope from 2 points and you wind up with a 0 in the bottom, you then look back at your points and see which coordinate stays the same between the 2 points. Here the x's are the same and they are both 3. That means you can immediately write the equation as x is always 3. And you can also say that this equation cuts across the x-axis at x equals 3. So the line has to be vertical in order to cut through the x-axis. If you happen to notice, before you tried to find the slope, that the x's are both the same, then you could just write the equation x is always 3. And if you compute the slope and wind up with a 0 in the top, then you look at the points to see which coordinate stays the same across the 2 points. Here the y's are the same, and they are 3. That means that you can simply write the equation as y is always equal to 3. And if you happen to notice that the y's don't change before you compute the slope, then you can simply write y is always equal to 3. And since the equation says that your line cuts through the y-axis at y equal to 3, it has to be horizontal or flat to be able to cut the y-axis. One more remark about the slope formula and how the points are arranged in it. Points are normally written horizontally like this. In the formula, they are written vertically, and all I did was to move the y value above the x value to rearrange the points so I could put them easily in the formula. This is just one of the points written vertically, and this is just the other point written vertically with the y values on top. So, if someone pre-labels the first point as point 2, simply place it in front of the formula and stand it on end, and the same if someone pre-labels a point as point 1. Place it in the back of the formula and stand the y value on top of the x value and just plug it in. This video originally started as a 5-minute brief explanation on how to place points in the slope formula, but I realized that I would not be doing it justice if I didn't explain the rest of it. If this video has helped you, and you feel so inclined, please visit www.essaysmadeeasy.com and donate. Every little bit helps, and thank you.